Okay, so this introduces another form. So this is called Bernoulli's equation. If I can get a differential to look like this, and it looks very similar to our linear form, the good news is we actually have a defined u substitution. So our u, whenever we see something that in this form, our u is always going to be u equals y to the 1 minus n, whatever n we end up with. Okay. So in this case then, so in our example problem, it's not quite in the right form, so I have to divide by x. So that says dy dx plus, and everybody gets divided by x equals xy squared. Okay, so what would our n be? Because it's now in that format. That means n has to be a 2. And so our u substitution is y to the 1 minus 2, which is y to the negative 1. All right, and then let me get myself a little space here. All right, we're going to have to do a couple of replacing here, a couple of additions that we need to swap out, because we instead of having just a simple dx or a dy, we have a dy dx. So we need to acknowledge that this is from chain rule, that if I want to replace that with a u, so dy dx is equivalent to dy du times du dx. And then I also would like to have an expression, or since I need to have a dy, that means I need to have a function in terms of y that I can replace that with a dy. So if u is equal to y to the negative 1, that would then, by the way, that means u equals 1 over y. That additionally should mean that y is 1 over u. Okay, so y is equal to u to the negative 1. In which case dy would be negative u to the negative 2 dy, and so dy du is negative u to the negative 2. All right, so let's just do some substitutions then. So dy dx we're going to replace with dy du times du dx. So the left side becomes negative u to the negative 2 du dx plus, and then I need to swap out y over x. So that's u to the negative 1 over x equals x, and then swap out that y squared, so u to the negative 1 squared. All right, so let's do some simplifying here. We want to, again, in order to use our forms, we have to make sure it's in the right form. So at this point, the problem with our differential is that negative u to the negative 2. So if I take that and divide everybody by that, write that a little bit clearer, we end up with du dx, and then that u to the negative 1 divided by u to the negative 2 is going to leave with the u up top, and then it's, oh, sorry, I didn't want to put equals there, so it's minus 1 over x u, and that whole expression on the right side is just going to simplify down to x. Okay, so what form are we now looking at? Which of our three main forms do we have? Because this looks like something we can handle going forward here. And this is our linear pattern, so we're going to find our integrating factor, which is e to the integral of negative 1 over x dx. So e, bring that minus out, So e to the negative ln of x, which is just negative x. Oop, I got excited there. It's yep. I need to bring up the negative up as an exponent. So e to the ln of x to the negative 1. Okay, so that's just going to give us x to the negative 1. Okay, so that's my integrating factor, so I need to go back and multiply that by every term. So x to the negative 1 times du dx minus x to the negative 1 times 1 over x times u equals x to the negative 1 times x. Okay, good news is this expression is an application of the product rule, and so we end up getting the integral of dx of x to the minus 1 u. And on the other side, we are, oh, that's a minus x. Oops. Where's my minus x? I think I have a minus that disappeared on me. Let me find it real quick. That was easy to find. Okay, so up here, this piece, right, this section, that little minus I misplaced. All right, so that's going to give me negative 1. All right, so that then says x to the negative 1u equals the integral of negative 1 dx, which is x to the negative 1u equals negative x plus c. And I want to solve for u. So that means I'm going to divide everybody by x to the negative 1. Alright, so that's going to give us u equals negative x squared plus cx. And then I can do my substitution for u, which was 1 over y. And then solving for y is pretty quick. That's just swapping out the right side with the denominator. So y, well, let's do that. So 1 over, and let's go cx minus x squared equals y. And so there's our nice fancy final answer. Yay!